period of a few hours, one afternoon, one morning actually. And it was quite a thrill to have that go off as well as it did. Give a lot of credit to the company that managed to pull it off. After we got things welded up, we started to do tests moving the antenna. This is one of the first times we tried to move it in elevation just to prove that the bearings all worked. And then it was time to start to put the reflector surface panels that had been made into position. So here they are being staged down at the base of the telescope, and we bought this crane to put things up. And here's a little picture of the putting in one of the individual panels. Each of these guys is like 5 meters long, and so you start to see us filling in the structure. This is where they were in September of 2006, and at that point I was saying to people, well, there's no way we're going to meet this November 2006 deadline, but well, we did. So here is President Fox, who came to visit us, and stood in front of the telescope to have his picture taken. The telescope's a bit of a cheat in this picture. The only real surface panels are actually the inner, about 1/2 of the area. The outer part is plywood. So we, but it's nice, you know, it's covered with aluminum foil or something, and so it looks pretty nice, doesn't it? And, you know, in the end, after some reluctance on our part, or I guess, you know, some wonder on our part of why this was all necessary, when I saw the whole thing completed and President Fox standing in front of it, I said, well, of course, you know, you had to do something like that. So we're glad we did. To make the first light detection, we built, UMass built a little receiver that we put up here at the prime focus of the antenna, and we just illuminated the inner part so we weren't having to deal with the plywood. Then President Fox came up, here he is, and he hit a key on our computer, and the antenna traced across this bright radio source M87, for those who know good old M87, a giant elliptical galaxy, no Virgo cluster. That was our first light ceremony. It's traditional in astronomy when you get first light, I mean, even at a long wavelength, for everybody to sign the chart. And so President Fox signed the chart, and I signed the chart, and everybody else in the room signed the chart. And then I was thinking, well, this is great, because now we'll have this swell chart with the president's signature on it, hanging on the wall in the control room, and because that's what you usually do with these things. But President Fox took it with him. You know, the guy had spent $20 million on this, and so, you know, by golly, he was going to take that piece of paper. They faxed us this so I could include it in the talks and so on. And here we all are, and this lady, Ronna Erickson, is one of my engineers, and she was the only lady in the room. President Fox, when we said, can we have a picture taken with the team, he said, well, of course, you know, hey, la muchacha. Okay, so we had and here's Dr. Serrano, my counterpart on this. And, these guys all look kind of tired because basically they spent the previous couple of weeks, up late, up early, working real hard to get to this point. And I can tell you, nobody on Earth believes that we were able to do this. Okay, so a bit about the science instrumentation itself. I mean, the real instruments are being built in our labs at UMass Amherst. You know, when you go about setting up a project like this, you select instruments that are basically picked because of their ability to use things that you think are particularly important for the science that you want to do. I hope I'll be able to make that case later when we're talking about the particular science program. And one of the other features of this is that it's taken us so long to get the telescope built that some of the instruments have been completed. And as they've been completed, we've used them on other telescopes and managed to get some science out right away with So the LMT, in terms of its scientific impact, it really already has some scientific impact, which we're kind of proud of. But this is a list just to show you that I'm serious about all of this. This is a list of the instruments. This guy, Sequoia, is a 32-element heterodyne array receiver. That may not mean very much. It's basically like a camera with 32 pixel elements in it. Now, since you can go down to the, buy disposable cameras with millions of pixels in them, 32 might not seem like very much, but in this business, 32 is the biggest in the world. And this is one of the things that our group does, better than anybody else in the world. In fact, we retired the world's biggest array to replace it by a new array that was twice as big. So, and we've been using it on our own antenna, and I'm not sure if I've got a figure. I think I've got a figure. We've been using it on our own antenna out here in New England and Western Mass for a number of years. We need a device called a spectrometer to go with this that allows us to look at spectral lines with the receiver. So we actually have a very powerful, in Western Mass, we have a very powerful mapping system for millimeter wave astronomy. The other instrument that we've built and it's been completed is an instrument that's called Aztec. We were discussing this today. Aztec stands for Astronomical Thermal Emission Camera. I won't even bother to tell you what Sequoia stands for. Aztec, there's a website called it's basic. It has some funny acronyms, but it's the website where they compile the list of all of the really improbable zany acronyms that people use in astronomy, and it's quite a long and funny list. And Aztec is, in some sense, the poster child for that. It's also a camera with 144 elements in it. It's not for spectral line observations, but it's strictly for continuum observations, looking at the black body emission from dust in our own galaxy and other galaxies. And we've been using that for the last year or so at a telescope in Hawaii. And this guy has currently been sent to Chile to go on a Japanese telescope in Chile while we're waiting for the LMT to get up to the point where it's useful to use it. Here's an example of some of the data that we take with our telescope in Western Mass, which we're just about to decommission, by the way. And our focal plane array. This is an image of the region of the Taurus molecular cloud complex. It's a set of dense dark clouds in constellation of Taurus. And just to give you a sense of the scale, here's the angular size of the moon here in the corner. These clouds, if your eyes were sensitive to this particular kind of radio emission from molecules in the clouds, are enormous on the scale of the sky. There's a lot of very exciting little intricate structure where low mass stars are forming within the knots and things that are present. And a lot of the structure is roughly related to the magnetic field in the cloud and aligned with the magnetic field in the cloud. For instance, there's some kind of striations over here that are aligned with the local magnetic field. So it's quite a lot of information in a picture like this.
I have a question.
Yes.
That one you said 32 pictures.